Hello. Hello. Can you hear me? Am I audible? Hello. Am I audible? Okay. So, yeah. So, this is your first session mainly. So, let's wait for maybe 2 3 minutes, 2 more minutes for others to join. So, if you have any doubt, you ask. I mean, you can interact. Otherwise, we will start after 1 or 2 minutes. Okay. Let other joins. Okay. Yes, Sati, you raised your hand, so you want to say something? I'll present also. I will share my screen. So I hope the screen is visible. Okay. Screen is visible, right, guys?
Yes, sir.
Okay. So welcome to the first tutorial for the week 1 for the engineering mathematics course, which is the second course. I also was TA for engineering mathematics first one. So this will be kind of continuation after after the first one, the engineering mathematics first. But yeah, you can learn if you know few definitions in one variable, discontinuity, differentiability, and derivative, continuity, and differentiation, all these things. If you know little, then you can do like the first lecture, first week tutorial that you can do. So I am Rahuldev Ghorai, so I'm doing a PhD in Isa Thiruvananthapuram in School of Mathematics. So I'll be one of your tutor for this course, and it will be mostly on the Sunday from 3 o'clock to 5 o'clock. Okay. So without saying anything more, we will start the start the tutorial mainly. So we'll mainly solve the tutorial questions or in the neighborhood of tutorial questions. Okay. So we'll mainly solve the tutorial questions and the around of the tutorial questions. Okay. So yeah, anyone else, like anyone want to say something about the tutorial? How it will be much like the better than this? I mean, better than this means better than the around of the like they will as I said, I will mainly solve the tutorial questions and the around of the tutorial same kind of things. So those are okay, or you need something more also. And also you it is open for question answer also. I mean, if you can ask your doubts from week 1. So it is not only the problem solving, just you can also ask doubts from the week 1. Okay, week 1 mainly has the scalar function, vector function, I mean the vector valued function, scalar valued function, and the gradient, how you define. You knew the derivative in the for the scalar valued function. So now what will be the gradient? You know partial derivative, which was in the engineering mathematics 1 course. So now how you define gradient, something called gradient. So all those things we will see here. So you have any doubt from like in all these things, or all these things are clear? I mean, partial derivative and continuity for function of several variable, those are okay. So shall I assume those and proceed? Excuse me. Okay, so I can't see your message, so I have to see the other device to check your message. You can unmute yourself and you can tell me. Okay, so that is how that will be better. Okay, so yeah, I am assuming that you know this partial derivative, all these things. Okay, so now to begin it, I'll say about the like something little bit interesting things are there, which I will just say briefly, and then we'll start with the question answering only. And I will do those little bit theory which are interesting and also will be useful for solving the questions. Okay. So to begin with, what I start the we you know, if you say like x equal if you have three this x equal to ft, y equal to zt, z equal to st. Means t is a like real number. Sorry. Okay, so t is a real number. I mean, it is in a real number set. So you know a function, or how we write a function in real numbers. So real number to real number is like a t is a real number which goes to f of t. Right. Now, if you have such three functions like this, and if you define this rt is a function which is like this, right? This is a like in three variable. If you think it's in the three variable, it will be in R3 space, where this is, let's say, I cap, it is j cap, k cap. I am assuming all these things you know, I just going through it. Okay, so this rt, what do we do? Rt is equal to ft I cap plus gt j cap plus ht k cap, which what it gives for a real number t. For a real number t, it goes to r of t, which is component, three component, ft, gt, and ht, right? I mean, which is x, y, z. That's what it is written here. So then that type of function will be vector valued function. You see here it is not only one value, it's a 3 component. Right? When one more than one, we usually say it is a vector, but in a more mathematical way, everything which is in a vector, some vector space kind of things are there. Those we are not anyway going through it. So in this course, you can understand in this way that is more than one component. I mean, it's not in R, it's R2 or R3 or more than that. Since this number of component can be 3, 4 like this. So all these things will be vector valued functions. So instead of scalar valued function, only one component. If it's more than one component, that will be vector valued function. Let's say it is RT is example I have given. RT is this. So can anyone say how this function will look like? It's a simple function. We say RT is equal to cos t I cap, sin t j cap, and tk cap. I mean, you can think it is like RT is a vector valued function is nothing but defined like this cos t, sin t, and t. So what will be the like how it will look like if you draw like let's draw like this maybe. So I mean if you draw something z is also there, then how it will look like, how your art will be.
Cylinder.
Sorry, I can't hear you. Say, no problem. We will learn by like this only. So, how to see this type of how it looks like? That's what I am asking.
Sir, it look like a cylinder.
Why? Yeah, that is a like a good first choice, like first guess. Yeah, that's a good first guess. I mean, what will be your x? I mean, RT is XYZ, right? But how your x will look like cos t? Y will look like sin t, and Z will look like t, right? So to know a graph, what we know, I mean, how we find. Usually, if we have a relation between x, y, z, right? Then we know about the graph. I mean, if I say x square plus y square plus z square equal to 1, you know that is a sphere, right? At least that thing you know, right? X square plus y square plus z square equal to 1, that is sphere. But in this case, what you see, x square plus y square is equal to 1 and z is varying like it is t. I mean, you do not know whether z explicitly depends on, I mean, it does not depend on t, means it always depends on t, and what you will see, it will be a circle, but z will always be increasing. So you will see it will be like this and this, and it will keep on going, and the radius of this thing will be, I mean, the radius will be 1 because this x square plus y square equal to 1. But z is varying, z axis, this is a z axis, right? Z is varying here, so you cannot do anything with Z. See, if Z was 1, or like let's say x equal to cos t, y equal to sin t, and Z equal to some 1. Let's say Z equal to 1. How your curve will look like? Yes. So then it will be like x square plus y square equal to 1, but z equal to 1, right? I mean, if I write it proper way, x, y, z, these are 3 axes, okay? Let's say here also x, y, z, x, y, and z. So your z equal to, let's say this is 0, 0, 1. This is a z equal to 1, right? When z equal to 1 will be the plane. Z equal to 1 will be the plane, like this plane. and in that plane x square plus y square equal to 1. If you visualize, these are not easy to make you understand by just drawing pictures, so you have to just visualize a little bit. So that is the, then it will be the only, if I draw, that is the curve will be the line will be this only. I mean this x square plus y square equal to 1 and z equal to 1 where it intersect, right? Okay. So I can't see your message. So just try to like unmute yourself and tell if you are if you want to tell something. Okay. Okay. So hopefully you understand. I mean understand. I mean yeah. What is the vector function? I mean by a vector function you can give a function definition of a like to be a vector valued function you can give. I mean, you can give tuple, two tuple or three tuple, means we sometimes say n tuple. Okay, so mean for a number x you are giving mainly some uh, f1 f2 not f1 f2 let's say, yeah, x squared 1 by x, that is also will be a vector valued function. It is not maybe defined many places because of 1 by x, but it is a vector valued function. So when you are giving fx is equal to this tuple like this 1 by x, right? So these are vector value function. Now we'll give the little definitions of the function f that assigns a single scalar value to each point in space, that will be scalar valued function. What is the definition of a scalar valued function then? F of x, y, z. If you have f of x, y, z, it will be, let's say it is equal to x. That is also a scalar valued function. Instead of f of x, y, z, it can be also x, y, and that is, let's say it is x square plus y. That is also a scalar valued function. But when it comes to a vector field, when this is, then it will be called scalar field. F is a scalar field, and this type of function, if you have, that's what I already have discussed, then it will be a vector valued function. Now limit, you know already this, it should, the limit at x naught, y naught, z naught exist, then like when which whatever way you approach to the x naught, y naught, z naught, you should get the same limit. All those things I hope you know. And the continuity then, and the differentiability. Differentiability is partial derivative should exist and they are continuous, then it will be differentiable. Otherwise also some other definitions are there for differentiability. Okay. So then there are like directional derivative, something called directional derivative, that also you already know that, I think. So this gradient of, if you know gradient, right? So you have f is a function, scalar valued function. So gradient of f will be, and that is differentiable. Let's say partial derivatives exist, and f is x, y, z, and that gives some scalar value. Okay, then it will be del f del x, del f del y, and del f del z, right? And if you want to know in a direction what is the rate of change of the function f, it's not in maybe x-axis and y-axis or z-axis. If it is in through x-axis, it will be del f del x. Through y-axis, you know. Through z-axis also you know. But what will be the rate of change in a arbitrary direction? Let's say u is the direction. Then it has to, you have to take dot product with u. Okay. So this, that is a, yeah, there's a gradient, and this now when you have for a scalar function, you know gradient. Gradient will be a vector field. Gradient of a scalar function will be a vector field, because you see that three tuple is there. Now gradient, divergence, something called divergence of vector valued function. That is divergence of f. Okay. cap, or what you write this gradient dot f. So you can remember it like this. So gradient is an operator who is like del x del y del x del y del x del x del y del z times this f dot. So when you take dot product with this, so this one will give you nothing but del f1 del x plus del f2 del y plus del f3 del z. So remember, this is now divergence of a vector function becomes scalar, right? I mean, divergence is a scalar field which acts on vector function. Similarly, curl also. So these two are, I mean, it is important. It will not, it will be, it is important already. And the known things that if divergence is zero, then it is something called solenoidal, and if curl is zero, then it is irrotational, all these things, right? Irrotational vector field. I mean, it's not rotating, it's moving, but without rotation. If the curl is zero, then you can determine that fluid, that you can say that that fluid is not rotating. All these things are there. Okay, so let me give like that these are the some basic things. Okay, now the examples of vector fields are this. So I need one more page, then I will move to the question. Okay, so this gravitational vector field for gravitational force field, which is F, is like this. So how it will look like? F will be, it's a component, let's say F1, F2, F3. Anyway, this gravitational force field is in already known thing, and it is in physics books and all. Okay, so this F1 will be mg small m capital Mg over r cube times x. F2 will be m capital Mg r cube by y. See, you see, and F3 will be this times z. So this is a gravitational field. Force field describes the force of attraction of Earth on a mass m. Okay. So how much force of attraction is on a mass m by the Earth? That is this force, and that is a vector field. Okay, this is a vector field. Okay, now it comes to this vector field. So can anyone say about this vector field? I mean, how it looks like? Can anyone draw the this vector field? How does this looks like? Okay, so let me draw it maybe a little bit here. You see, I mean, if I'll give a brief idea. So let's say 10 point. So what will be f of 10? 0, 1, right? Right. So then it is in this direction. So if you calculate f of 10, sorry, 0, 1, let's say 0, 1, then it will be minus 10. So if you, this is 10 point, right? So 0, 1 point. So then it will be minus 10 in this direction. So if you take minus 10, this will be in this direction. And if you take 0 minus 1, this will be in 10 direction. So you will see this under this vector field. If you keep something, it will actually move in this direction. I mean, it will try to rotate. It will keep rotating. So that's why it will rotate the vector anti-clockwise. So this is anti-clockwise direction by pi by 2 angle, right? So yeah, this type of thing you will see in the nature. You see, this is the thing. This is the, I think you will find it most interesting, which is a vector field representing Hurricane Katrina. Okay, see how it looks like. So they calculated all these things, and they found out this is the vector field when Hurricane Katrina, Hurricane this is the vector field. I mean, Hurricane Katrina happened. I mean, you can represent the Hurricane Katrina by this vector field. See, that's the thing. That's it. It's a small thing I draw here. I have drawn here, but the more complicated thing, of course, is here, and that is like this. And always you see when cyclone or something is coming, this type of rotation things are there. These are nothing but vector field with some directions are also there, and by this you can predict many things. I mean, predict the like how much velocity and all these things it is coming through and all those things. You know all these things hopefully. So yeah, that's a vector, one of the vector field which comes in nature, and you see always most of the time you see in the news the cyclone and all. That's the, yeah, that vector field is representing. Okay, so yeah, any doubt please let me know, otherwise I'll start with questions. Okay, next is question, nothing else is there. Any doubt?
No, sir.
Okay. So anyone else? So if you have doubt, please let me know. I'll just wait for 1 minute maybe for you to ask doubt, then we'll start. Once we start the question, we don't have any theory. We'll try to solve questions, and you can also try by yourself. We'll be doing together. Okay. Okay. So then this is the first question. Can you try to do it? I'll not give much time, but just at least read first the question. Then we'll solve it. Okay.
Sir, option 1 is correct.
Okay,
Hello.
let others do. I do not know whether first one is correct. I will ask you, okay? In 1 minute, I will ask you why. But yeah, let others do. Okay, so anyway, this is a easy question also. But yeah, please tell me why you are feeling so. So the first thing is, for a vector valued function, it is a rich component as I told always. And something to be differentiable, it has to be all the component has to be differentiable, or continuity also, it has to be continuous for the all the components, right? So RT is continuous. I will say RT is continuous at a point 0 if all the component are continuous at 0. Okay. So now we'll see about LNT. How does this looks like if I am, this is my T, then how does it looks like this, right? Ln will be at 1 0, it is 0, otherwise it is increasing, and less than 1 it will be decreasing into and it goes to negative infinity kind of. So LNT is defined even on, it is defined on R plus, right? So all these three you it cannot be because sorry, I have made mistakes. So these two cannot be possible because R plus LNT is not even defined in negative numbers, and these 2 and 4 they are including negative numbers, right? So these two are gone. Now let's come to the second one, 1 over minus t minus 1 whole square. So this is not defined at t equal to 1, right? But it is telling that it is in the third one it is telling that 0 to 1, 1 belongs to this 0 to 1, and it is telling that the RT function is continuous on 0 to infinity means 0 to 1, but at 1, 1 over t minus 1 whole square is not defined even. Continuity limit. I mean, as t tends to infinity, all these will be infinity and all those things, right? So, the only option remains is option 1. All of you are okay? So, these type of questions were there. I mean, I changed little just part of question I did, but not much. So, it's a kind of same question, first question it was. Is this okay?
So when t tends to 0, tends to minus infinity.
When t tends to 0 mean you have to say 0 plus and then
Yes,
lnt will be, yeah, that will be minus infinity. Yes, that's
but
true.
at 0, LNT is not defined.
Lnt is not defined even.
So it
Yes.
is not continuous.
Yeah, it's not continuous. Yes.
Okay, thank you.
Also, infinity is going to infinity. You cannot put any value and you cannot say anything about that. I mean, if lnt had some number ln0, I will be, let's say I am defining it as some x, some number, but that x number and minus infinity cannot be equal. I mean, you cannot equal that thing. I mean, when it is
Yeah,
going to,
yes, yes,
cannot
sir.
do anything there. Continuity. Yeah. If it was lnt is equal to some, it is going to some finite number, then you could have just defined ln0 as something, then you can say, you can do something like if you remember sine x over x, limit
Yes,
as
yes.
x tends to 0 it is not defined, but you can define it because the limit exists and limit is x tends to 0 is 1. I will somehow define, if I define sine x by x equal to 1 at x equal to 0, then it will be continuous. So
Yeah,
that
yes,
time
sir.
there you can do what here you can
Yeah.
do. Okay, so anyone else has any doubt here? Hopefully no, but just I can't see the message. Okay, I see the message. Okay, so this was the first question. Okay, no doubt it seems because no one is speaking also. Okay, yeah, this is the answer also. I have given already, and this will be already this will be shared with you later, but it will be shared with you in the Google Drive. So you have the answer also. I have written it. So that is not also issue. So now do the second question. What will be the derivative of this? So this will be also easy. Let's see, and then we'll have some more other questions are there which will be difficult, but this is also easy. So, but yeah, let's do it. I'll see whether you know all these things are already. So anyway, if you don't know the how to find the derivative of a vector valued function like this, then what I say is that will be also, I mean, this is like kind of parameterized vector valued function. So in this case, so you do the
Sir, option 3 is correct.
sorry, hello.
Sir, option 3.
Are you telling the answer or I mean I don't understand.
Sir, answer.
Which one? Third
One.
one you're telling?
Yeah, yes, sir. Option third is correct.
Okay, okay, we'll see, we'll see. Okay. Anyone else?
Option C, sir. Option C.
Yeah, maybe three. Okay.
Answer C, sir.
Yes, tell.
Option
Third answer.
3, sir.
Okay, okay. So we'll see. See, LNT, DDT of LNT, how we will derive? So first T times DDT of LNT
1 plus L and T.
and DDT of T, right? So that will be 1 plus LNT. Correct. But all the options has this 1 plus LNT. So next e to the power root T DDT of this. This is nothing but e to the power square root T times DDT of square root T, that will be 1 over 2 root T, right? So yeah, this option goes because these are negative, these are still there, so we have to see sine of t square, but they just kept it sine of t square, so we have to take derivative of sine of t square, ddt of sine of t square, right? So that will be cos of t square times ddt of t square, that is 2t times cos t square. So all of these things you see it is here, so this is correct answer, and whoever said third, they are correct, and that's what it is written also. Okay, yeah, now you do. This is what is the, which of the following is the tangent to the curve at t is equal to 1?
Sir, option 1 is correct.
No, how you did that I will ask you. Okay,
Okay.
Option 1, sir.
How you got that? How did you evaluate? Tell me, no problem. Tell me.
The equation of a tangent to the curve is given by vector r plus lambda times r dash at point.
RT plus lambda times R
Ah,
prime T, right?
yes, sir. At t is equal to 1.
So anyway, yeah, you know, but others, all of you know, right, already? I mean, you have, I think these are already in his lecture notes. I mean,
Yes.
lectures, I mean, videos also, okay? So this you have to remember, this RT plus, I thought you don't know, but see, you can check how it comes also. See, it is not just RT plus lambda R prime D. It should be, there should be a way to get this formula. Okay. After you know formula, you can, if you want, you can check. Otherwise, you can just remember it. Okay, that's not a problem. But when you do RT plus lambda times R prime T, now you know how to find out R prime T. So R prime T will be derivative of T first. That will be just 1 times I cap plus negative of e to the minus t j cap plus 1 by t k cap, right? Right. So then if you put at t equal to 1, right? At t equal to 1, what will be that? So rt is first component will be 1 plus this lambda times r prime, this is 1 plus lambda times I cap plus first one will be e to the power minus 1, like rt for this one e to the minus t, and this is where e to the minus of e to the minus t, right? So, and lambda is there, so 1 minus lambda times e to the power minus 1 j cap, and plus it will be 1, and it is ln of 1 is 0, so it will be just lambda k cap. So first one is correct. The solution is also given like this, and yeah, try to find out the unit normal vector to this surface. So what is the definition of unit normal vectors?
Gradient of f upon mod of gradient f.
Option 1.
Option 1 and 2.
Gradient of f over modulus of gradient of f, right? So what is gradient of f? You found out? I will verify that whether we have done. Okay, tell me one of you.
Sir, y plus 3x square z square.
Good. Very good. Gx square z square, and this will be
I can
x
x minus 2yz
2yz, and this will be minus y square
3 square plus 2x cube z.
2x cube z. Okay, then get, so at 101 you evaluate, so gradient f at 101, right? So what will be that? So it is 0, and on 1 is 3, and then it will be 2 yz, y
1
is 0, so constant 1, and then 0, it will be 1 2, right?
yes
So when you have 3 1 2, the norm of, I mean the gradient, the modulus of grad is f, that is nothing but square root of 3 square plus 1 square plus 2 square. That's simply gradient of f will be 14, square root of 14, right? So it will be 3 1 2 and 1 over square root of 14. That this will be the unit normal vector to the surface at the point 101, right? So if you have surface like this, okay, sorry, yeah, if you have surface like this is the maybe surface, then at 101 the unit normal is this. So you can find it if you know this formula, and that's it, using gradient. See, it's not easy to find for just given a uh, given a function, and you need to find out in the unit normal vector to that is, there's a surface. If you read this will be a surface in 3 dimensions, and the unit normal to the surface will be this, using this formula. Okay, so the solution will be then, first one you see 3 over square root 14,
first and
1 over
second.
square root of 14, and 2 over square root of 14, right? That is okay. This can never be, because 2 over 14, but this also can be a thing, because square root 2 over square root 7 is nothing but 2
1
over
2
square root 14, right? So this is also correct, this is also correct. So 2 should, 1 and 2 both are correct, right?
yes sir.
Okay. See, these solutions are there also, I'll share. Okay. Yeah, this is also a good question. So which of the following is the equation of a tangent plane to the surface z equal to ln x plus y?
Sir, please explain how to find tangent plane to the surface.
Sorry?
Sir, please explain this concept, tangent plane to the surface. This is not clear to me, sir.
This is not done.
No, this is done, but it was not clear to me.
So there's a equation of a, right? So you mainly have to find out the derivatives and all. I mean the del x, del y, del z, and if you remember some x minus x naught times del x of the function plus y minus y naught times.
Well, okay, sir. Okay.
You remember now? Z
Yeah.
minus z naught times del z. So now try. So that will be the thing. So it is written here z equal to ln x plus y. So this function, one function you can write like this: f of x y z is equal to x y ln x plus y. right? And then the tangent plane of the surface, this given by this f will be this del x f times x minus x naught del f is equal to 0. This will be the surface tangent plane to the surface, right? So these are all these things you can uh, mainly derive by yourself if you know
Sir,
the
f of
little bit. Sorry.
x y z should be written as ln x plus y minus z, na?
This is f of x y z is equal to x y. Sorry. Yeah, that is
ln
true.
x plus y minus z.
True. I was writing in the vector valued function. You cannot do any partial derivative also. Sorry. Yeah, this ln x plus y minus z. Yes. When I will do this del x f and all, then I would have just got the idea that it won't be like the third like this vector valued form. It's a scalar valued function, of course, because it's a surface line, right? Surface. So this surface equations here also you see this surface equation. This f of x y z is written as a scalar value.
Sir, option 1.
Sorry.
Option 1 is correct.
Option 1. Well, let's see how
Yes.
it goes. Okay, hint for the solution is this. We'll do it here. Okay. So anyway, if you want to do in this z equal to f of xy form also, that also can be done. I mean, that formula is little bit different way it is given, but when z equal to xy, if you want to find the tangent line, so then it will be del z del x, or yeah, I mean del z del x del f del x. So that at the point you want to find out, let's say here it is p at p point times x minus the p point minus del f del y. So whoever has done, so try to do in this formula also, x minus p, sorry, y minus p. I mean the p is first component, p is second component. Okay, that's the p plus z minus f of ab is equal to 0. So are you getting the same answer with this and with also this? In this case, f will be that f will be z minus, I have written already, or ln x plus y minus z. Whatever you do, that will be same x ln x. So these two formulas should give you the same answer. So we'll see that. Okay. So f of x y z, first we write in that other form, f of x y z is ln x plus y minus z. At which point you have to find p is equal to 1 1 1. If p is 1
Option
1
1,
1.
sir.
Sorry.
Option 1.
Okay. We'll see. Del f del x at 1 1 1 is 2, right?
2.
1 by 2,
Yes,
right?
sir. 1 by 2. Sorry. Yes, sir.
Yes. Del f del y will be same. Del f del y, so I am not writing, skipping that because it is the same, will be 1 by 2. Del f del z is minus 1, so at every point it will be minus 1. So what will be the thing then? X minus 1 times del f del x at 1 means half, plus y minus 1 times half, plus z minus 1 times
Minus
minus
1.
1 is equal to 0 will be
Tangent plane. Equation of the
the
tangent
tangent
plane.
equation of the tangent plane, right?
Yes.
So then x by 2 plus y by 2 minus z will be negative 1 plus 1, right?
Yes, sir.
That implies x plus y minus 2z is equal to 0. What is that? X plus y minus 2 is equal to 0. X plus y, this is wrong, this is wrong, this is wrong. So this will be correct in one. The one process is telling this one is telling it will be this. Also, let's do in the this form. Okay. What is this one? This form is, this is telling ln of z is ln of x plus
X plus
y.
Y.
Then you do z del x at 1 1, that will be 1 by
1
2.
by 2.
Del z del y will be also 1 by 2 at that point, at p mainly. Okay, at p it will be 2. Now del z del x time x minus y times means x minus 1 times half minus y minus 1 times half. Sorry, it will be plus only. Okay, yeah, this formula should be plus. Plus z, z will be this z, just z, it will be minus f of ab minus ln
F of AB. From where you got this?
1 1. I see. I think there is a, that's why I just
1.
wanted to clarify whether this one is correct. I don't think now it is correct. Yeah, so ln of this coming ln of 1 plus 1
1
together.
plus 1.
So it should not be the case. But I found someone was, somewhere it was written that this formula also correct, but okay. Okay, so leave it anyway. Okay, I just I will see anyway. So this one for now, don't use this one.
Sir, the term F of AB is suspicious.
Sorry?
Minus F of AB. This term
Huh.
is suspicious.
Minus f of AB.
This term is suspicious, sir.
Yeah, but
I
it was
think
z
yes, sir.
minus AB, so that's why I was thinking that maybe it will be. Okay, okay. Tangent plane, if it is at A, B, and f of AB. Okay, okay. Understand. So this is tangent plane at this point, A, B, and f of AB. Okay. So in our case, these all are one. So everywhere you have to put P is equal to 1 1 1, but this quantity f of AB also will be 1 in this case because the last component is 1. Then is it coming? I mean, this is negative negative, and then this is, so if I do it now, so it will be negative of this, and plus z minus what I told, this is 1, z minus 1. Now is it coming? This is will be 0.
Sir, what is F?
What is f? F is already said that ln of x plus y.
But if we put 1 comma 1 here, x is equal to 1, y is equal to 1, then we are getting ln 2.
Z
Sorry. I mean, what I was telling that a 1 and 1 point. So f of AB, we have to choose in such a way that f of AB is 1. But then we don't get. So there is one book where it is written that the surface tangent plane to the surface z equal to f of x plus y at the point AB and f of comma f of AB will be like this. But can we get 1 for this AB f of AB? So it's maybe it is not possible, right? So if we put 1 and 1, f of 1 will be ln of 2, right? So yeah, in that case, I think it should not like it won't be.
Yes, sir. Please discuss in next session.
Yeah,
Yes,
that's the thing. That's a good thing.
thank you.
That's why I'll try to discuss this one using this method in the next class. Okay,
Yeah, yes.
but you have already one answer using this one. I mean, this f of this is very much clear, right? This with this
Yes, sir. This
with
one
this
is
x.
easy.
Yeah, also easy also. Yeah, that's true. So whenever is z equal to f of x plus z equal to f of xy is there, you try to do it like z minus ln of x plus y as whole f, or you can also you can write f of xyz equal to ln of x plus y minus z also. That is also not a problem. Both whatever you do, it will be coming same answer, and you use this equation as a tangent plane equation. So the last one we did tangent, that was the one more we did, right? This is a normal vector we did, and before that tangent to this parametric curve. This is a curve which is parametric curve. For this it was like RT plus lambda times R prime T, but in this case it is, yeah, this is for a surface. For the surface it will be, formula will be this. Okay, remember this. So yeah, next we'll go to this. So in the next class I will try to verify with those both formula whether it is working. Okay, now this directional derivative, which you already have told about, the directional derivative is, you know, del f del x, you know, del f del y. So can you give me the rate of change of the function in the direction I am asking? I mean, that is the 1 1. I mean, the direction is 1 minus 1, but at the point 1 1. Direction is here, you remember 1 minus 1. You just see it, I cap minus j cap, but at the point 1 1.
Sir, is there one more discussion session today?
That I do not know. I
Sir,
think it
from
might.
6 to 8 p.m.
Yeah,
mentioned
yeah,
in the.
yeah, 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 I think so. I think so. If I remember correctly, it will be from 6 to.
I think there are two TA for this
Yeah,
course.
yeah, yeah, yeah. 2 TS that I know. 2 TS.
Yes.
Timing I was not sure.
Option third, sir.
Sorry?
Third.
Third. Okay. How you did? Done? How?
Sir, please discuss.
Sorry? B is the answer.
Directional derivative equal to
Directional
gradient of
derivative equal
f
to
dot unit
directional
vector
derivative means at 1 minus
direction of
in the
I
direction
minus
of
b.
sorry. Directional derivative at 1 right?
Yes.
Of a function f
Dot
times 1 minus 1 right? Am I correct? Yes? Yes or no? Tell me, gradient, what is gradient of f?
unit vector of 1 minus 1.
Gradient of f will be 2x comma minus 1 by y, but gradient f at 1 will be 2 and minus 1.
Minus 1.
And now if you take, because you want to find out this, so this will be 2 minus 1 times 1 minus 1 is equal to
Sir, how will this give directional
Minus 1 by
derivative?
root 2.
also, yeah, that is a unit norm, unit vector also you have to find.
1
So
minus
that
1 upon root 2.
that norm also you have to divide. That formula, that's why I was asking. The formula is correct. So this is the norm also you have to divide, right? So then if you divide by norm, so this will be norm of this vector, sorry. Yeah.
1 minus 1 upon mod of 1 minus 1.
Square root of 1 square plus minus 1 square,
Minus 1.
right? So that will be root 2. So it will be square 3 over square root 2.
By root 2.
I mean, when you take the direction of the vector, this you have to normalize. I mean, you have to give the unit vector along this direction. So that is the mistake we were doing. So that always you have to take in the unit normal vector. Means you have to make it unit normal. Okay. The norm of, I mean, the distance will be 1. It should be 1. Okay. So,
Sir,
okay.
can you discuss this geometrically? This question.
Sorry.
How can you interpret this question geometrically?
How can I?
Can you
See,
demonstrate? Yes, sir.
see, if when you have, let's say this is x, let's say only 2 direction. Don't forget about 3 direction. Let's do in the. I mean, think about this one, x, y. So when you want to know the rate of change in this direction, what you do? So let's say you want to know at x naught. So what will be that? So you do, if you change little bit here in this way or this way, so this will be x naught plus h, and you keep y fix, y as it is. If you want to know x naught, and let's say 0, if you want to know x naught at 0, and then it will be change like, and then f of x naught 0 over h, and as limit h tends to 0, this gives you del f del x at x naught 0, correct?
Yes, sir.
For y also, in the this y direction also you can similarly do like this. So by this, what you know the rate of change in the direction of x axis or in the direction of y axis, right? That's
Yes, sir.
what you know, right? And you see this quantity will be nothing but gradient of f at x naught 0 times 1 0, right?
Yes,
Am I correct? So this is why, because del f del x at x naught 0, gradient is nothing but like this, and del f del y at x naught 0. When you take dot product with 1, 0, what will be that? First component with this one and second component will be 0. So this will be only del f del x at x naught y 0. So what you see, del f del x, and you can see that is for any point also you can write del f del x at any point will be nothing but gradient at that point of f times 1 0, and this 1 0 you see this is a unit direction and that direction is which direction? This is 1 0. So in this direction, the x direction. So this is nothing but a directional derivative. The partial derivative is also a directional derivative in the x-axis through in the direction of x-axis. Similarly, del f del y is the directional derivative along the direction y-axis. So the natural question arrives: what is the directional derivative in this direction? Till up to this you understand?
Yes, sir.
Right? So what is this direction? This direction you can maybe name it at some a b, and then people try to find a b f. So that's the theory. Then you can say that a b, this will be the directional derivative, this will be the change rate of change through in this line, through this line,
So
in this
divided by
direction.
under root a square plus b square.
Exactly, yeah. Always, I mean that AB I am assuming now this AB is unit vector. Okay, so that I am forgetting. So yeah, otherwise if you forget then you just write a square plus b square also, of course. The unit direction. That's why 1 0 you see it is already unit. You don't need
Yes.
to normalize it. So that's why actually it comes the this direction derivative in any direction if you want to know the change of the function, and that you know it is always useful. It's not only the in two direction only, but other direction also important. And how people do that? So any a b you can write as a times 1 0 plus b times 0 1, right? So you can use this thing and some other computation to show the directional derivative. This is nothing but gradient of f at ab times ab, because 1 0 direction through 1 0 direction and through 0 1 direction you know, right? So you now you need to find out some scalar multiplication of 1 0 plus some other scalar multiplication of 0 1, right? So those are different things, but at least you understand this. The partial derivatives, just usual standard partial derivatives, are also directional derivatives, but in the direction of x-axis and y-axis, only two axes. But you can have any direction you want, and then you need to. That's the directional derivative, the general directional derivative in any point.
Yes.
Okay.
Thank you, sir.
Okay, no problem. So where we were? So question 6. Question 6 is then done. So I will now give you one good question. I don't know whether good question. I mean good question in the sense. Yeah, it's a little different, but you can do maybe. So you try this. So find directional derivative. I am not writing full name of phi is equal to, I mean phi of x y z is equal to x y square plus y z cube at a point 2 minus 1 1 in the direction of normal to the surface x log z minus y square plus 4 is equal to 0 at 2 minus 1 1. Can you read the handwriting? I mean, I think it's readable. I will just make it a different color for you. Okay. So you try to do this one. See, more you practice, more it will be easier for you in the exams and all. So you don't need to study anything more if you just try to do it now by now itself. So shall I wait for some time, or I have to do? If you are trying, then let me know. I'll just wait for a few minutes. Okay.
Minus 3 root 2.
Yes, sir.
Done.
Yes, sir.
What is the answer?
Minus 3 root 2.
Minus 3 root 2. One, like two of you are telling, right?
Yes, sir.
Both of you have same answer?
Yes, sir.
Minus 12.
Minus 12.
Yeah.
Someone got minus 12.
Yes.
Who else? Who else? Tell. 1 minus 12, 1 is minus 3 square root 2. Anyone else? So you all know first of all what we need to find, right? So we need to find gradient of phi
Yes, surface.
at, let's say this is the point P, okay? I'm naming it as P. Gradient of P at P dot a vector which we have to find, right? That is a normal vector to the surface. Okay, that we will find. But what is gradient of phi at P? Gradient of phi will be y square.
I cap plus.
No, I'll be writing like this. This you can
Okay.
write y square I cap plus something at j cap, but I can write, we can write also like this. Y square plus 2xy plus z cube, right?
Yes, sir.
And then
Ty z square.
z square. So gradient phi at the point 2 minus 1 1, I mean that is P, that will be equal to, first one is 1,
1,
Minus
comma,
3. Minus 3.
minus 3,
so 1 and minus 4, this is minus 3, right?
minus 3,
Minus 3. फिर.
and minus
Again.
3,
This will be
then minus
3
3.
times minus 1 times 1 square is equal to minus
Minus
3.
three.
Okay, so this first quantity we already know. So now the thing is we need to find the vector, that normal vector which is the normal to the surface. We already know this formula, how to do that. So you do this gradient type of things, right? So x minus, sorry, I mean normal direction, you want to find out the direction. Okay, so then this gradient of f over
P.
norm of f. Norm means the distance from 0, right?
Right.
So that will be what? I mean, first of all, gradient f, you try to find out gradient f. Gradient of f. F is this, okay?
Log z.
Log z.
Minus 2y x by z.
2y.
X by z.
Comma x, y, z. Yes. Sorry. So then gradient of f at the point
2 minus 1.
So that will be 0 first of all. What 1?
0 to 2.
0, 2, and x is 2 over z is 1, so 2, right?
Divided by 2 root 2.
So this will be gradient f at p over that norm of the same thing will be 2 square root or 1 over square root times 0 square plus 2 square plus 2 square, right?
2 root 2.
So 8 is 2 root 2, 1 over 2 root 2 times 0 to 2. Okay?
Okay.
Yeah, so I'll maybe just write the answer here. So then the required answer will be gradient phi at 2 minus 1 1 dot 1 over 2 root 2 0 to 2. That will be 1 over 2 root 2 times minus 6 plus minus 6. Plus will be minus, no? Right?
Yes, sir.
Right. So it will be,
Minus 12 upon 2 root 2.
yes, so minus 6 over root 2, that is nothing but minus 3 root 2, so you can write. Okay, so someone who told that it is minus 12 seems to be incorrect, but you try to go by this way, and where you made mistake, you can find out, I think. Okay, if you have mistake in the in between, so there are two steps only. One, you need to find gradient of phi, which is you know already, but the another one only, the thing is the direction, in the direction of the normal to the surface. So you have to find the direction to the normal of to
Sir,
the
I think,
surface. This, yes,
sir,
tell. Yes,
I think she has not divided by 2 root 2.
but he or she was telling that
Minus
it
12.
is only minus 12 or 12.
Sorry, sir, 12.
Yeah, yes, sir. I didn't divide that one.
Okay, okay, no problem, no problem. I was not, yeah, it's not a problem, but it is
Yeah.
good that you were interacting. That is the thing. I mean, you will understand what is the mistake. See, this type of mistake you will not do in the exam hall when you learn here, right?
Yeah, okay.
And those people who are not doing at all, they will make mistake. That's the main general thing. I mean, a normal thing. People try to make mistake in the exam halls. So that's the thing. Okay, good. But yeah, that's this mistake. I was doing because I also forgot things many days. I'm not in touch with these things, and I also forgot to divide it by this norm of this one previously also, if you remember. So these are common mistakes people does. So yeah, you have to practice, that's all, and do this. Okay, so now let's do this one then. Seventh question. This will be easy. I will try to find out some good question. Okay,
Sir,
sorry.
solenoidal means curl must be 0.
No,
Curl.
No,
del
that
dot
is
f bar. Gradient
Divergent.
is.
Yeah, okay, okay. Thank you.
that
Divergent
is
of F equal to
irrotational,
0.
irrotational. Okay, I will write solenoidal. Dull means divergence of f is 0, and irrotational means curl of f is 0. Okay, if you don't, I mean, if it is difficult to remember, then remember like this. See, rotational has R, and in your curl you have R. That common thing is there. So here you don't have that common thing. Means whenever this curl is there, then irrotational will come. Okay.
Yes, sir.
Initially, if you want to remember, I mean, it's a weird way to remember, but yeah, that's you can.
Second option, A equal to minus 2.
Sorry.
Yes, alpha equal to minus 2.
Yes,
So
sir.
Alpha equal to
alpha equal
minus
to
2.
minus 2.
Okay. All of you are getting?
Yes, sir.
Yes, sir.
So divergence of f will be, just divergence f will be, this will be del x means 1 plus,
1
this will be also 1
plus
plus alpha
alpha.
is equal to 0. Then alpha equal to minus 2, right?
Yeah, yes, sir.
Oh, I heard you told 1 minus 1. Okay, okay, it's a minus 2, right? Whatever the divergence. So divergence is this divergence of f is nothing but if you have f has 3 components, then it will be del x of f1 plus del y of f2 plus del z of f3, right? And that's why you get this 1 plus alpha. And for solenoidal to be the vector, one vector field to be solenoidal, it has to be the divergence will be 0. That's why this quantity is 0, means alpha has to be minus 2. No other choice. Yeah, this one. This is divergence of f. So gradient dot or divergence, they are same operator doing this. Okay, now do this. I have just given him the solution is this, and irrational if curl of f is equal to 0. And I have given the solutions of video also, but you try to do it. Maybe it may not be correct also, the solution.
Second option.
Sorry? So if someone forget the definition of curl of f, that is like I cap, j cap, k cap, del x, del y, del z, f1, f2, f3, right? In these
Sir,
cases,
B
f1
and
is
D.
f1 is f2 is. Sorry, tell.
Sir, options B and D are correct.
Okay, you have verified it. I have already written the solution. My name is just in this given. But yeah, if you have uh, checked this, then it's okay. I mean, you have to find like this. So just to know you have done it, that you are doing it nicely. So I'll give you one more in this direction, that x plus 2y plus az times I cap plus bx plus 3y minus z j cap plus 4x plus cy plus 2z k cap. So find a b c so that f is irrotational. Just quickly find it, okay?
Sir, A, B is equal to -4, C is equal to 1.
Wait. A b is equal to,
-4.
all of you get same.
No, sir. A equal to 4, B equal to 2, C equal to -1.
Okay, so yeah, I have to also see the answer maybe. Uh, yeah, now tell the answer. A equal to 4.
Yeah, sir.
-4.
Most probably it will be equal to 4. B equal to
-4.
2. C equal to -1.
-1.
Okay, so this should be the correct answer. Okay, let's do maybe. So I cap, j cap, k cap, del x, del y, del z. Then you have x plus 2y plus az, bx plus 3y minus z, and 4x plus cy plus 2z, right?
Yes.
This determinant you have to take. So I cap times del y means c, only c, and del z will be -1.
Plus 1. Minus of
minus
plus.
-1, right?
Yeah.
Plus j cap times del z is a minus 4, right? So whatever whoever has done the -4, that will be not be correct. So k cap times b minus
2.
So to be this one to be 0, because this is equal to curl of f, right? Curl of f, that is equal to this determinant, I mean this vector value vector, and then this is like this, and then it will be 0 if and only if c equal to -1, a equal to 4, b equal to 2. So that's the correct answer. Good. Right? So now one more interesting question. Okay, not this. One minute, guys. I found it. Just yeah. So you try to prove this one. If not in this class, maybe you can try it at home also. So r to the power n, and this r vector is rotational and solenoidal only when n equal to -3. R to the power n times r. R is square root of x square plus y square plus z square. Okay, this is standard in like polar Cartesian coordinate, and r vector will be x, y, z. Do you want to try this? It's very interesting. Or if it, I don't know whether it will be too big calculation, too long calculation. If it is so, then you can do it at your home also. Give your home as a homework maybe. You try for 1 or 2 minutes. You see, you will see that whether it is gonna be difficult. Okay, and let me know. I think first even try solenoidal one, right?
Yes.
No need to do iterational first. Solenoidal you do first. Is it difficult? I mean,
Sir, in the solenoidal itself, we may get n is equal to -3.
oh, okay. That is great then. I mean, okay. So, what you need to find maybe f of x, y, z is equal to okay x square plus y square plus z square to the power
N by
n
2.
over 2 times x, and I cap, j cap, k cap, all these things are there. I am not writing this quantity and this quantity with z only, right? Okay, let me write it nice, not like this. I mean, you can write this as x square plus y square plus z square to the power n over 2, sorry, n over 2 times x comma y comma z. Okay, that's the thing, that's the function. So now what will be gradient f means del f at del f del x. So it will be a little bit computationally, I mean, time taking, it will be n by 2 minus
Minus
1
1.
times 2x square, right?
Yes. Plus
Yeah, then it will be again plus of,
x into x square plus y square plus z square to power n by 2.
no, 2x square plus not y square.
X into
Sorry,
x into
what x into?
sir, this term plus x into x square
No,
plus y
only
square.
x square plus y square plus z square whole power n by 2.
Yes, sir. Okay.
Exactly, x square
Yes.
plus y square plus z
Plus z
square to the
square.
power n by 2, right?
Yeah.
Then del f del y,
By symmetry, sir.
exactly, it will be same. So what you have to say, what you have to say in the solenoidal, right? Means if you just add all of them,
Hmm.
right?
Yes.
Del f del x plus del f del y plus del f del z, because divergence has to be 0, right? Okay, so it will be little bit it will have less to maybe. Okay, so what it is coming anyway.
3
So
times x square
this
plus
3 times, yeah. So 3 times x square plus y square plus z square to the power n by 2 it is coming, right?
yes, sir.
Plus n by 2 and 2 always will, you can
2
delete
times
it, right?
2 cancel out. Yes, sir.
X square plus y square plus z square to the power n by 2 minus 1
Into
into
mm,
all the x square plus y square plus z square will be coming, right? Because for y you have y square, for z you have z square.
yes,
Am I
sir.
correct? So
Yes.
that is nothing but divergence of f. So what you are getting 3, and you see this plus this times this will be n by 2 minus 1 plus 1, so n by 2, so 3.
So
Where
there will be n, sir, n times.
yeah. Here n is the 3 minus, so 3 plus n
Yeah.
times x square plus y square plus z square over n by 2 minus 1. So all of the time, if this has to be 0, if n equal to minus 3.
Sir, only n by 2, sir.
Yeah. Not power n
Ah,
by 2 minus 1.
1 by n, only n by 2, not n by 2. Correct. So if n equal to minus 3, then always you can guarantee that this is 0. But when n equal to not minus 3, then when x equal to 0, y equal to 0, and z equal to 0, then also it is 0. But for all other values of x, it is not 0. So the condition which should be strictly is n equal to minus 3 for solenoidal. Also you will see for irrotational. So this is general type of vector functions, I mean vector field r to the power n times r. So you can say that when n equal to only minus 3, then only it will be solenoidal or irrotational. Otherwise it cannot, it can never be. Okay, so if you in the exam, if you see this r square times this type of vector they give, then it will not be solenoidal and or irrotational or some other thing also. Okay, okay, now this one. So you want to do today anything more, or to leave. Okay, to do 9th question and 10th question I have maybe. Otherwise, I'll share all these two also with you. That is also not a problem.
Option 1.
Option 1 is correct. Let others do, I'll tell you. Okay?
Yes, sir. Option 1 is correct, sir.
Okay, let's see this thing. Work done is 0. Okay, so option 1 is correct. So you can see the answer here. The work done is given by this C, and when x equal to t, y equal to t square, you just put this thing and you will get. Okay, right?
Sir,
Yes.
sir, can you explain the limit of the integration?
Sorry.
How you got the limit of the integration?
Limit of the integration. Here.
Sir, using y is equal to t square, how will we get this?
No, I don't understand. See, what you have? Y equal to x square type of curve, right? So we parameterize it like t, then the other point will be then t square, because x and y we need, right? Y equal to x square. So
A, sir, A.
how this curve will look like is this, right? So along this curve, if you want to go from 0, 0 to 1, 1, 0, 0 to 1, 1. So what you need to see, this t, if you vary from t, if you vary from 1 to 0, this t comma t square will give you this whole thing, right? So that's why you get this curve, this up to this, from here to here, you get due to the, because you have to go from 0, 0 to 1, 1 maximum you can. So if you vary t from 0 to 1, this along this curve we will go from 0, 0 to 1, 1.
Sir,
That's
we
why.
have we
Yes.
have y is equal to t square. Okay.
Yes.
So if I put y is equal to 0, then we get t is equal to 0. And if we put y is equal to 1, then we get t square is equal to 1. So we'll be getting t is equal to plus minus 1.
No. We are changing everything to t now. T is equal to 1, not y equal. T is equal to, we are changing from t to, when 0 less than equal to t less than equal to 1, you get full C.
Okay.
C you will change, C will be from 0 to 1, and here x will be t and y equal to t square you put. What I am telling is x, sorry, y equal to x square is equivalent to, y equal to x square is equivalent to t square. This point, this parameterized point, right?
Yes, sir.
And now we want from 0, 0 to 1, 1. That line you want is C. But in this,
Sorry.
that is in this frame, in this
Yeah.
frame. But in this frame, what will be that? That change will be t from 0 to 1, right? Is not this equivalent?
Yes,
Their
sir.
equivalence are like this. And here
Okay.
what you do, this x equal to t, y equal to t square. That is how you get this one. From this one to this one, you get using this parameterization. So that's why we do like this.
Sir, is parameterization always necessary?
No, but it makes your life little easier. Otherwise, you have to use some other formula, because the c is not a like just usual curve. I mean, when see integration over c, but c is a curve, right? So you cannot just write it is not a something 0 to 1. I mean, one interval. If it was interval 0 to 1, then you can just write 0 to 1. In that case, you don't need to change anything. Here, you have to change to interval, and to make that, you have to do parametrization. Parametrization you are doing in such a way that you are varying from 0 to 1, but you are getting a curve. That's a parametrization.
Sir,
And on
sometimes,
that, yes.
sir, sometimes parameterization of a curve are very difficult. So how
Yeah, in
should we
that case,
proceed?
yes, there. I don't think there are a very general way to find always the parameterization of a curve. I mean, it's not always easy, but this type of case you will see it will be easier and the calculation will be easy.
Yeah, okay, sir.
Yeah. Okay, so this is okay then. So last is this one, arc length. Arc length, the formula is given like this. I mean, arc length will be this ddt of like r prime t. Arc length will be r prime t, that norm, and that norm, you know, this x component square plus y component square plus z component square. See, r prime t is components of this, so you just take, and then you take 0 to 1 integration. So this will be square root of 5 at the end answer. Okay, so I'll say this anyway.
Sir, how if sir parameterization of a curve is not given, then how could we find the
Sorry,
arc length of? Sir, if parameterization of the curve is not given, then
parameterization of a curve is not given.
and
So
it is very difficult to find the parameterization, then how can we find the
there
length
are
of?
yeah, I mean for a curve, I like say that f of sorry. I mean, if you let's say you have like this curve is mainly you are telling I mean a curve which is maybe in 2 dimension or 3 dimension, whatever is that. I mean 2 dimension. Let's say you want to find this, so you have to find mainly the length from here to here, right? Okay. So if you know the parameterization, you know what you do. This you take the tangent vector at each point. You know the tangent vector, and you take the norm of the tangent vector. Then you just so what we do, this rt is some ft I cap plus gt k cap plus ht k cap. So anyway, here you are not, yeah, I say, yeah, of course, parameter. So of course, it is given in terms of t, only t. But otherwise, also you have to do integration, but not maybe this 0 to 1 form. So you have to find maybe other type of difficult integration. Integration will be difficult. But if you don't know, if you know the parameterization, things will be easier. When you do not know the parameterization, this thing again it will be remain this derivative of this each component again. That makes sense, right? That will be okay. That is not a problem. So for this type of problem, article to ft I cap, some three different function, three different tuple is there. Then it has to be like this way.
Okay.
But what you are asking is arc length of the curve which is not like parameterized, right?
Yes, sir.
So in that case also, how it might look like t comma ft, right? It has to be like some function. So we can parameterize like at least this way, t comma ft. The function is given f of x y, or somehow it's something is given, then you can write like this to make it parameterized, right?
Okay.
Sorry.
Sir, is there any equivalent formula in terms of xy of arc length?
I mean, when you are writing it as a
In
xy,
terms of
just
Is
xy
there any
function, right?
Cartesian form? It's a polar form. If any Cartesian form is there.
I mean, this is like you after parameterize only people do, and this parameterization can be done. I mean, not like it cannot be done. I anyway, if some formulas are there, I have no idea. I don't think there are some general formula for general thing. I mean, it's usually people do like if x t y t, then it will be square root of x prime t and y prime t. I mean, the x prime t square, then y prime t square, like this. I mean, and then you take integration over how much the length from where to where you want.
Sir, in two-dimensional space, there
When one, see, from here itself, one thing you can see. Yeah. Let
under
me
root
say.
1 plus dy by dx whole square.
Something you see, because y is equal to x. Sorry.
F of x, suppose.
We
I
can
mean,
convert y in terms of x, then we can make it as a line integral.
exactly. F of t gt, right? What we were doing, g prime t square plus f prime t square, that is square root of this one, right? And then, but in this case, this dx dt is nothing but g prime t, right? And dy dt is nothing but f prime t. So now if you take this dx dt whole square and dy dt whole square, it will be something like dx dt whole square plus dy dt whole square root of this, times you have this dt,
dt.
right?
Yes, sir.
Integration you take. So now like as a like some bogus step, I mean some if you just formal calculation gives you square root of dx square plus dy square, and it you will cancel, and that gives you if you take dx common, let's say dx common,
Outside, yes, sir.
so it will be 1 plus dy dx. So this one you can maximum, this type of things you can say. Yes, that is good. Yeah. So this one maximum you can say. I think this is what you wanted to know, right? Or
So, for three-dimensional space, can we proceed similarly?
dy dx that then it will be dz dx plus dz dy, that whole square.
One more term, sir.
Yeah, one more will be there. One more dz dx will
Ah,
be there.
okay, sir. Thank you.
Okay, then any other questions, or otherwise we can end this session for today's. So these are the books and references which Professor Jitendra Kumar also suggested. So you can go through any one of the book, or just go through his lectures and you attend the TS classes, then it will be easy. I mean, it will be okay. Also, one of the book you can refer, but yeah, otherwise you can just go through videos and come to the tutorial classes also. Okay, thank you for your
Thank you,
attendance.
sir. Thank you, sir.
Thank you,
No
sir.
problem.
Thank you. Thank you.
See you in the next class. Okay.
Thank you.